Hey guys, another episode of Yo at Home. Right now I'm going to look at what happens when two air masses meet. Alright, so let's think of a cold air mass over here and a warm air mass over here. Which one would be more dense? Which one of these puppies is going to be the dense one? Consider what warm air molecules are doing. The reason they're warm is because the molecules are moving back and forth very, very, very fast. What a cold air molecule is doing? Well, they're moving slower. Which ones can get closer together? The cold ones can get closer together because they're moving slower. That makes cold air also more dense. That makes warm air less dense. So if cold air starts to move this way, what is it going to do to the warm air? Is it going to slide up on top of the warm air or push underneath the warm air? Well, I think you probably got that right. It's going to push underneath the warm air. And that means a cold front looks sort of like this. Now, this is the top of the troposphere here. The cold air pushing in here. And what's going to happen to the warm air when it meets it? The warm air suddenly is going to be lifted up. Again, what happens when air is lifted up suddenly? Dun, 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 dun. It reaches its dew point, and then you form a cloud. In this case, you're forming one big cloud because a lot of warm, probably moist air is lifted up suddenly. This is a cloud that can produce serious thunderstorms and all those dangerous things that you would imagine. And if you think about the thunderstorms you've ever experienced, when they were all done, the sky probably pretty quickly cleared and it got cooler. And it probably all happened pretty quickly. That's a typical cold front. This is a thunderstorm very often. Does not have to be, but it's going to be that kind of cloud. A cumulus cloud that as soon as it starts raining, it's cumulonimbus cloud. Thunder, lightning, all of that. The more violent weather, always associated with a cold front. They come in, they move very quickly through. If you're playing outside, by the time you notice these big clouds, you have not very long before they're on you. They are moving quickly, often 25, 30 miles an hour sometimes. So by the time you see it, you might have half an hour before it's on you and thunderstorming. That is a typical cold front. You might have also half an hour before it's now past you and done thunderstorming. And then the weather changes and clears and gets nicer. That'd be the weather in a typical cold front. In a typical warm front, things are going to be a little bit different. In a typical warm front, the air is now going to have it moving this way, cold over this way, and we remember if the warm air is moving this way, well, it's less dense. And if it's less dense, that means when it hits the cold, it can't push under the cold, which would be a very efficient way to move. Instead, it's going to slide up over the cold front like this. That is not an efficient way to try to move the cold air out. And in fact, the cold air is going to move slowly. And that's going to figure prominently in when we study how the big storms all work. So if the cold is moving slowly on this warm front, changes the situation entirely. First of all, from the time the warm air is actually on the ground to the time you see the very first clouds associated with it, which are cirrus clouds, those very high clouds about 7 miles up that look like little mare's tails. By the time you see those, the distance between that and this could easily be 1,000 miles. All right, you say, what about a cold front? Typical cold front from here across might be 10 miles. That's a huge difference. Okay, so by the time the warm front gets to you from you first see it, it might be 24 hours by the time that gets you. And all that time, the clouds have been thickening, going from cirrostratus to altostratus, to plain old stratus, and very often nimbostratus, because it's starting to rain. This would be the warm front suite of clouds. Cirrus, cirrostratus, altostratus, stratus, nimbostratus. Notice the thing they all have in common? They are all stratus. That's right. All stratus. And what does stratus mean? Layer. Layer clouds. Right? Well, thunderstorm cloud, these are not stratus cloud. These are cumulo clouds. In this case, cumulonimbus. Nimbus just meaning raining. But these puffy clouds are the result of air going up quickly. These stratus clouds are the result of a huge mass of air going up very slowly and gradually. So they get thicker during the day. Remember, the way to see which kind it is, you use the sun. If you could see the sun through the clouds easily, and it hurts your eyes to look at, you're looking at cirrostratus. Not much has blocked out the sun. If the sun you can see, but it's not very bright, doesn't hurt your eyes so much to look at, you're looking at it through altostratus clouds. And if you can't see the sun at all, you're looking at it through stratus clouds. So the warm front weather will take a day to show up. By the time it starts raining, they say it'll probably take on the order of a day of gentle rain. Sort of that wet, rainy day, not raining ever too hard, just a gentle, calm rain. Not heavy winds, gentle, calm rain. At the end of that, it starts getting warmer. It gets muggy. It depends on the season of the year. It may get somewhat more or less pleasant. If you would like warm, muggy air, wintertime, yeah, that might be nicer. In the summertime, it's not as nice. Usually we wouldn't think. But you're in the warm sector then of this storm. And the funny thing is, warm front shows up first, almost all the time. And a cold front follows right behind. Now, why does it work that way? We'll have to see in our next lesson of Yo at Home.